Hello everyone, this is our fourth lecture. Here we will discuss about calorimeter. What is calorimeter? This is our topic today. Okay, now the first question appears, what is this calorimeter? A calorimeter is a device which can basically measure the amount of heat exchange. Means if you just keep two liquids, one hotter and another colder, if you mix one hot liquid with one cool liquid, what will happen? They exchange heat. Heat comes out from the hotter liquid or the hotter system and it goes to the colder system until they both reach a common temperature. Clear? So during this process, heat is exchanged, some amount of heat is taken, some amount of heat is released. And calorimeter's work is to measure the amount of heat taken or left out. Now, to measure the amount of heat taken, we must need to understand that the formula for calculating the heat is Q equals to mc delta T, where m stands for mass, c stands for specific heat capacity, and delta T stands for temperature change. So how does this calorimeter helps us, and why can't we do it without a calorimeter? First of all, what happens inside a calorimeter is very simple. Inside a calorimeter, we keep a cold liquid. Usually we call its temperature T1. At T1 temperature, then we add another hot liquid with it. Externally, a hot liquid is poured. Consider its temperature to be T2, as T2 is hotter one, so T2 is greater than T1. So what will happen now? Heat will exchange between the cool liquid and the hot liquid. Clear? So inside this device, this happens. Now the question appears, we just observe how do we calculate this heat exchange. How do we calculate this heat exchange? You can see this is the calorimeter. What are the parts of this calorimeter? The calorimeter is made out of a copper vessel. Okay, now the question appears that why do we use copper? Why copper? Easy. First of all, it's a good conductor of heat. It's a good conductor of heat. So if you just mix two liquids, one hot and one cold, it just helps to reach the temperature very fast. Second reason is its low heat capacity. When we are mixing two liquids, you have to remember the container also gets some amount of heat. Now if the container is made up of copper, its specific heat capacity is low. So the container will take less amount of heat. So most of the amount of heat will be transferred or exchanged between them. So very less amount of heat exchange occurs. Very less amount. is absorbed by the container, so a copper vessel. Now, heat is not only goes out through the container, but heat can also flow out more in three processes. The three processes are very simple. All of you mostly know these names. Radiation, convection, and conduction. Yes, these three processes: radiation, convection, and conduction. So first we need to understand how can we stop this, because if from the calorimeter heat moves out through radiation or convection or conduction, we will not be measured the accurate amount of heat exchange. The accurate amount of heat exchange cannot be measured. So we need to take some necessary steps inside a calorimeter. First of all, to stop radiation. To stop the radiation, we make the walls polished. If we polish these walls, the shiny outer surface will not radiate much amount of heat, as most of the heat will be reflected out. So there is not much possibility that it will leave out the good amount of heat. Now the next one, we take conduction. Conduction means flow of heat outside. Flow of heat outside means this, if the copper vessel is hot, it will flow heat outside. So how can we stop it? Now it is actually kept inside a wooden jacket. It is kept inside a wooden jacket, and this internal space filled with poor conductors of heat. They are filled with poor conductors of heat. Like what? Like wool, like cotton, this kind of heats which will not let the heat outside because they are poor conductors. Fine. So we enclose the copper vessel by wool, cotton, and the last process that remains is convection. Convection means the heat will move just convected outside, means it will just flow upward just like a liquid evaporates. Similarly, the heats can have the ability to convection. So to cover that thing, we put wooden lids on top. We give wooden lid on top of the vessel. These wooden lids also stops the convection heat transfer. So now we have blocked all the methods of heat transfer, that is radiation is blocked, convection is blocked, and conduction is also blocked. So all the heat transfer will happen inside the calorimeter. That is why calorimeter is very much required to measure the amount of heat exchange, because it actually insulates the total liquids, the total heat transfer process from the outside. Now after that happens, the things are very simple. We know I just need to calculate mass, specific heat capacity, and temperature change. Mass can be measured very easily. Measuring the mass of a liquid is not a big deal. specific heat capacity can be known from any kind of given chart. If you know the name of the liquid, you know the specific its value. Just like for water, it is 4200 joule per kg Kelvin, and more on you can find a list in your book. So knowing specific heat is not a big issue. What do we need to know? At last, the change in temperature. To know the change in temperature, we kept a thermometer. Very easily, the thermometer tells us the amount of change in temperature, and this thing is called a stirrer. It is just used to move and just mix the liquid very properly so the heat transfer can happen uniformly. So after the heat transfer can happen uniformly, the thermometer tells us the change in temperature. If I know the change in temperature, mass and specific heat is already known, we can calculate the amount of heat exchange inside a calorimeter. And this is a very simple thing, the calorimeter. This is how it helps us in measuring the amount of heat heat exchanged. So that is why calorimeter is very important. Our next video will be on the principle of calorimetry. I hope all of you have understood. If any doubts, ask me in the comment section, or you can also inbox me. Thank you everyone.